welcome everybody to the second online workshop of the Balkan Speleological Union. And for those that were not with us last time, I'm going to say it again that in the Balkan Speleological Union, one of our targets is to bring together cavers from around the world and to offer a context in which we have the opportunity to share knowledge. So I'm opening this invitation now for everybody. If you have any kind of subject that you would like to share with us, an expedition, an exploration, something that you have been working on, just let me know, and I can deal with organizing an online event. And today, I would like to welcome Zach. He is the director of the National Speleological Society of the United States of America, and he's an active caver since 2017. He's experienced in cave exploration and Karst survey, and also leadership as being a director of a caving association, and therefore he will walk us through exploration behind the computer. He has been working with drones and ground penetrating radars and resistivity surveys, and also LiDAR analysis. Therefore, he has there you see CaveFinder app, and I found very interesting how Zach developed an app with which we can prospect the field in order to find caves even before we step on the rocks on the karst. So therefore we will have Zach presenting his activity, and at the end we will be able to stay for a chat, for questions, answers, and you can open a beer. You can, I don't know, take some snacks because the entire workshop is one very informal and like in the Balkans. So again, Zach, thank you very much for accepting my invitation, and the floor is yours.
Thank you so much for the invitation. Thank all of y'all for having me. I'm really proud and very excited about CaveFinder, and I enjoy sharing it with cavers. So we'll get started here. So LiDAR has been used for around probably a couple of decades by cavers to look for caves, but it's been pretty difficult for the average caver to use. You have to have sort of knowledge of how to use these GIS programs like QGIS or ArcGIS. You got to know how to hunt down the LiDAR data itself. You have to know how to use the various methods to analyze LiDAR data. And it's a real headache for most people. When I first started caving, I was really curious about it, and it took me years to really wrap my head around it. So what is CaveFinder? It's really easy. It's a website, it's an app that you can access on your mobile device or desktop browser, and you basically you go to somewhere you're interested in looking for caves on a map, and you draw a box on that map, and CaveFinder is going to give you a ranked list of cave candidates. No special GIS knowledge required. There's no technical barriers. If you can scroll a map and draw a box on a map, you can use CaveFinder. So when I first started developing CaveFinder, I felt good about being able to make it, but I still had to ask myself, well, how am I going to go about doing it? So I'm going to spend the first part talking about the science of it and how CaveFinder works. It might bore some of y'all, but I'm sure some of y'all are going to be interested in it. Here's the methods I researched to look for caves using LiDAR data. There's quite a few of them. They've been published by cavers, geologists, hydrologists. Some archaeologists have developed these. There's none of these created or invented myself. All of these methods are published research from a broader geomorphology and Karst literature. None are mine, but I did research trying to figure out what's the best one? Which one do I actually use for CaveFinder? How do these methods work? They're all various level of complexity, but they all work in a basic way in that the LiDAR data gets turned into a digital elevation model. A digital elevation model is like a smoothed out version of that LiDAR data. Then the individual methods can score those individual cells of the digital elevation model, and it can rank candidates based on that score. I know that sounds a little complicated, and it really is. And some of these methods are so complicated, it's hard for me to wrap my head around them myself. So what I quickly figured out in developing CaveFinder is that there wasn't really a single method that was best. Some methods call it real sync, but they also call it what we call over here in the states borrow pits. It's just where they took soil, gravel for construction elsewhere and construction scars. Some methods call it hillside hollows, but they also lit up road cuts and drainage ditches. Some methods caught features that others missed, and that was a common one. So a lot of methods picked up some caves and missed some caves, and then other methods would pick up caves other methods missed. I started realizing there was an overlap, but each method seemed to have its own value. Weaker methods missed a lot of caves outright. Stronger methods found the right feature, but they also found a lot of other, they also flagged a lot of other features that weren't caves. They're called false positives. The solution I developed, thankfully, early on was that instead of just picking one method or two or three, I'm going to run all these methods in parallel, and I'm going to create a formula, an algorithm that decides how much to trust each one. Because even though each method does have its value, they're not all equally valuable. Methods are weighted based on real calibration performance. And I'm going to go into the calibration soon. Not only are there the detection methods that I showed you a few slides back, there are also scoring formulas that are applied as well. If more than one method says the locations of the cave, that's called a multi-method consensus bonus, and that's a clear and obvious, way that this multi-method analysis algorithm works. Depth to width penalty, it penalizes too shallow for size features. Build-up penalties, penalty near buildings, roads, and quarries. Sparse region gating, it penalizes areas that just aren't located in Karst, and it boosts areas that are. What does that give us once we run that? Well, I'll go into the calibration. I'm thankful that I'm a member of what we have over here. We have called state cave surveys. I have no doubt y'all have perhaps something similar over there. But since I'm a respected caver, I've been able to get access to a lot of the cave location data here in the States. And that data is what I use to see if CaveFinder actually works. I took 13,000 known cave entrances in 2 different states here. For each cave, I had a calibration tool draw a 1 kilometer squared search area with the cave placed somewhere random inside. I had to place it randomly inside the search area to prevent the algorithm from learning that the cave was always in the center, which it would do that, and that's not what we want. Then I ran the algorithm.
Interrupt. Should we see also the presentation?
I'm sorry, is there an issue?
It can't be seen. You need to share.
Did you see none of it?
No.
Oh wow, gosh, I'm so sorry. What are you seeing on your end?
Nothing is shared.
Geez, yeah, let's figure that out. What about now?
We can see your desktop.
Desktop. We're gonna get this. We had it working earlier, so I'm sure we'll get it. I bet this is it, right?
Yes.
All
Thank
right,
you.
so I'm gonna go through, sorry about that. Let's go through a few of the slides real briefly that I passed. Um, these are the methods. I'm going to let y'all take a quick look at those in case you're interested. I'm happy this will also be recorded, of course, so you'll be able to take a quick peek at these later on the video. This is a map of what you get generated once you run an analysis with CaveFinder. I'm going to go more into this in a later slide. This is the no single method. This is just, thankfully, none of these slides are too visual, so we really didn't miss out a lot. These are the scoring formulas applied to every candidate. And again, these will be on the video that's recorded. So even though we're passing by this again quickly, it will be on the video if you're curious to look at these more in depth later. This we're getting caught up to where I was. This is the calibration. This is me going over the calibration info. So run the algorithm and check whether the real cave appears in the top 10, top 25, or top 50 candidates. Then the detection counts at 3 thresholds within 10 meters, 25 meters, or 50 meters of the known entrance. There's a reason why I did it at these 3 different thresholds, and I'll go into that as well. Here's the results of me calibrating and testing against 13,000 known cave locations. It's at 3 different distance thresholds. It's at within 10 meters, within 25 meters, and within 50 meters. And I've listed the top 10, top 25, and top 50. I know that's a lot of numbers I'm throwing at you, but basically, if you use CaveFinder to look for caves, you should find if there's caves there indeed, it'll give you a ranked list, and the known cave will be within 10 meters, in the top 10%, in the top 10, 12% of the time. On the other end, let's look at how often it puts you within caves within 50 meters. A lot higher, obviously. It's going to put a known cave within 50 meters in the top 10, 41% of the time, and in the top 50, 69% of the time. This sounds a little complicated. That's fine. I'm actually going to go into it a little more and it'll make sense. Something that'll be, so these numbers are actually outdated. These numbers are what is live on CaveFinder app right now if you use CaveFinder. But I've been working on CaveFinder a lot since then, and the new accuracy and precision numbers are a lot better than this. I'm still testing it. I have some users testing it just to make sure it's working good before I launch it to the actual CaveFinder app. This is exactly what that next step is that I just did to get better precision and accuracy numbers. I use machine learning. Previously, the weights and the scoring bonus formulas, I was just sort of taking a guess at based on like running a lot of different calibration over different numbers and percentages. I eventually figured out it's a good way for machine learning to take over and do it. So instead of the 10 detectors and scoring formula being hand tuned, the machine learner re-ranks instead and learns 13,000 real caves, what truly separates a cave from a false positive. It weighs all of a candidate's features at once and catches non-linear patterns the formula cannot, as in bigger openings are more cave-like. Some caves, some candidates, only the ranking math changes. Top 10 within 15 meters rises from about 41% to about 57%, that's a big increase. I validated this by using the meta ranker on one state cave database. Then after it worked there, I tested it against another. This means it's not learning on one specific region's data set alone. It does transfer to other regions. Why the 10-meter numbers look lower? So the cave data that I'm using has been gathered since like the 1950s. And back then, they didn't have GPS units. So they were sort of guessing somewhat at where the known caves were on the maps. And it has led to the known cave locations being sometimes hundreds of meters off from where the survey data says they are. So that's dragging down my numbers a lot. If I could have a data set that was just, within 10 meters of the known cave, that would bring the accuracy numbers of CaveFinder up a lot. Also, the data sets I'm using, those two states require 30 to 50 feet. That's a American number, but 30 to 50 feet of passage before they can be considered a cave. A lot of other countries and states don't have such a strict definition of a cave. So if I ran CaveFinder on those databases, it would also raise the stats without having to change the tool itself. Sort of a repeat slide. How to use CaveFinder. You go to CaveFinder.app, you draw a box, you receive a ranked list of candidates with confidence scores. Then you can export those candidates as a GPS file, a KMZ file, a KML file. These are all just location files I'm sure some of y'all are used to working with your GPSs. Also, it includes a ridge walk plan, which is pretty cool. It's going to give you the most efficient route to walk between points. And it's not just going straight line using closest distance. I'll show you this in a second. Here's an example of a ridge walk plan. So you decide which amount of points you want to look for. And then if you click the ridge walk plan feature, it's actually going to give you the route, taking into account elevation, terrain, and it'll tell you the most efficient way to go. A lot of people really like this, and they've asked me if I would release it separately so they could use their own points for it, and I am working on that as well. Some info that's going to be important to y'all over there internationally about how CaveFinder handles the LiDAR data. The detectors need high-resolution LiDAR, bare earth DEMs near 1 meter per pixel. That data is just not available internationally right now on a wide scale. In the United States, we're extremely lucky. The government here has gathered 1 meter LiDAR data and has released it publicly to be used for free or commercially, whatever public wants to do with it, they can use it. Outside the United States, high resolution coverage depends on national LiDAR programs, and those are available and out there, but it's usually a lot worse resolution. It's usually, instead of 1 meter resolution, which is what CaveFinder really needs, the resolution available internationally is often 30 meters, which is magnitude lower. The global 30 to 9 meter digital elevation models cover everywhere else, but they're too coarse to detect caves reliably. These files take up a lot of data, and I store them on a server so that they can be accessed quickly and easily. Because I have the server fees, and these are hosted on a server where even someone on a crappy computer for an old cell phone could use CaveFinder. That's not free for me to do, not cheap. So I do have a free version, which I've made to be, it should be more than enough for people to plan out their weekend ridge walks. And I did that intentionally. I was wanting the vast majority of users to find the free version more than what they needed. For power users, for people who are just like obsessed with looking for caves and want to do it for hours a day, multiple hours a week, I do have the pro version, and that's to help me with the cost of the server fees and whatnot. It seems like about 5% of the users have opted to do the pro version. So again, 95% of people are more than happy with the free version. But I'm about to give you a live demo of CaveFinder, but before I do that, I want to give you a warning because people like to use CaveFinders in areas where there are not any caves. And then CaveFinder does give them a list of candidates for that area. CaveFinder assumes that if you analyze an area for caves, you are determined to look for caves there, and it's going to give you a list of candidates. It can't create caves where there are none, and it's up to the user to use this program where there actually is some potential of caves. Now let's do the live demo. Got the website. Can y'all still see this? Are you looking at the website here?
Yes, it goes. It
Awesome.
works.
Awesome. Here's the main website. It goes over a little bit of stuff we've already talked to the presentation. So I'm just going to click this Open App button, in the upper right corner, it's going to pop up the same thing I just told you. CaveFinder cannot create caves where there are none. Please use this in an area where there's actually going to be caves if you want to use it in a realistic manner. Don't draw it over a parking lot or a non-karst forest unless you're just really determined to look for that. There we are, CaveFinder. I got some coordinates saved of caves. I'm going to just go run some. This is a popular pit cave in the United States called Never Sink Pit. Maybe some of y'all have heard of it. Let's draw this box right here. Yeah, that's a good one. This is a example of what a free user could do. Find caves. I can tell from how fast it's going, it already has the LiDAR data cached for this area, so it shouldn't take long. Over here on the right, I have land layers for, when I think about it, this is more specific for United States users. I have various layers to look through. Here's a LiDAR view, hillshade. I'm sure some of y'all are familiar with that. Street view, just going through some map layers while we're waiting on this data to load. All right, here we go. Looks like it's got us a candidate. The number one candidate, I'm not surprised, is the big pit entrance right here. But I know this area and I have access to the cave data. I'm not allowed to share that data publicly or I would have it in the presentation, but some of these other points are indeed non-caves. So here's an example of me using it in an area where admittedly I knew it was going to pick up that pit nice and easily. But it also picked up some other non-caves that are a lot smaller entrances. Let's say I wanted to do a ridge walk here and I wanted to walk these cave entrances. I wanted to walk these points and look for caves. I'm going to click this button over here on the lower left called Plan My Field Day. It's asking me where do I want to start. And let's say I'm going to park right here. Because generally you are going to park on a road or a parking lot. Let's say I had landowner permission to park there, walk the caves there. So there's my start point. I'm going to click Generate Plan. It's going to take about a minute, but it's worth seeing because it's super cool. Real quickly, while that's loading, let me show y'all something else because it takes a minute or two for that to load. This is a cave survey training simulator. This has nothing to do with CaveFinder. Just showing it to you while this ridgewalk plan loads. This is a 3D cave simulation complete with a working disto. Look at that. Doing the L-Rud. Right. Actually, not much. Oh, there's the ridgewalk plan done. I want to show y'all this real quick because people think it's cool. And I messed up a little bit, but that's just because I'm not a good surveyor. Anyways, this actually has a working sketch map. As you shoot the survey stations, you can sketch it, the plan, the profile, and section views. I think this is cool. Nothing like it exists yet. It's available for free on the CaveFinder website. Check it out if you feel like it. All right, bouncing back to the ridgewalk plan. Well, already it's popped up a ridgewalk plan. I mean, sorry, a ridgewalk view right here. It's taken into consideration distance between the points and elevation to get you there. Let's see what it just downloaded for us. Well, it's got the GPX file of those points for you to load into your GPS app of choice or whatever you're using. If you prefer KML or KNZ, it's there too. There's GeoJSON. You old school and you want a spreadsheet, we have that option. Let's open up the ridgewalk plan. I'm getting it open. It won't take but a moment. I've got it. There we go. There's the Ridgewalk plan. It tells us how many targets we have, how long that Ridgewalk walk will be, which it says it's 6.5 kilometers. Got the start coordinates. It has our elevation gain and loss, elevation range. This right here is sort of a elevation profile. It shows you what elevation you can expect to walk. This right here is the raw LiDAR DEM, which it looks like it glitched out. I see it's all pixelated on the right. I've never seen it do that. I apologize. I also do it live like this just so there is an error. Y'all can see it's not perfect. Here's the Ridgewalk plan on a LiDAR view. Here it is in a satellite view. Here it is in a topographic heat map view. And then down below here, it lists all of the individual ones and their coordinates. And it has a score, as in like, what's the best one? Which one should you prioritize if you're not going to check them all out? That is it for the CaveFinder presentation. I got done with it a little faster than I did last time. Sorry for the weird beginning where I didn't have the screen shared. I deeply apologize about that. I am a little embarrassed. Sorry, I feel like the saved video is not going to be that great now, but oh well. I'm available for questions. I'm so thankful to that y'all invited me. The one thing I'll touch on super quickly before questions, since y'all don't have access to great quality LiDAR data available right now, CaveFinder is going to have limited use for you. Emma gave me a heads up that some parts of the Balkans probably does have higher quality LiDAR data, and I'm going to look into that today and try to get that added. If I get that added, I'm going to reach out to Emma, and that way, hopefully, she has a way to like let all of y'all know, hey, Zach added the high quality LiDAR data to CaveFinder 4. It'll probably be certain areas of the Balkan. I doubt they all have it. Also, if there's anybody else hears of any good quality LiDAR data, let me know. If it's a public source, I can get that added to CaveFinder just for anybody that does scans in the Balkans or wherever that data is for. Sometimes there's private LiDAR data sources available that you can't necessarily make available to the public. In that case, I have a way for individuals to upload their own LiDAR sources into CaveFinder. I don't think I've actually turned it on where people can do it, but it's there in the back end. All I got to do is like change one line of code and it'll be turned on. So if people are interested in using their own privately accessible LiDAR data sets, I also support that, and I will make sure that works for you. And that's all I got. Thanks again for having me.
Thank you so much, Zach. I told you I'm a lazy caver, so for me, this is of major interest. I hate, I hate finding caves by foot. So I can see we already have a question from Stelios.
Thanks for the presentation, Zach. And I actually have 4 questions. So Emma, if you're chairing the meeting and someone else wants to speak in between my questions, that's fine for you to give them. And I hope I won't be taking up too much of your hospitality or time here. You already mentioned that for the Ridgewalk part of the application, you would not. I mean, first of all, I noticed it's only in the paid for software, and you're working on allowing us to plot a course for our own waypoint list. That's any idea when that might come, or if it would be a standalone project or an add-on to some other freely available terrain data?
So I will probably keep it a paid feature in the app people can still export their candidates without paying for it. And then, of course, they'd have to figure out their own route to walk those points. I might make it free in the future, but for right now, it's one of the few things enticing people to pay for it and helping me with server fees. What I have mostly got completed is
It would entice me as well. That's why I'm asking. It's
what I do have mostly completed is that standalone version, and I'm tentatively calling it something like Ridge Site. And what I'm viewing is I'm going to have a family of CaveFinder apps, and if you pay the $9.99 a month fee for any of them, you get access to the paid feature in all of them. And with Ridge Site, how I'm probably going to do that is I will allow people to use, like, let's say up to 50 points for free ridgewalk planning. And then if they wanted to use more than 50 points, they would probably have to pay that monthly or yearly fee. I'm still working on that payment, how that would work. I'm fine tuning the details on that. But I have that
okay.
mostly ready, and if you or people are interested in maybe testing it out, I need test users absolutely. So and I'm trying
I
to make I like to make them as I'm trying to make these apps like as good as they can be. So I mean, it's even if the feedback seems minimal, I'm all ears for it.
well, I spend my summers in a place that has plenty of potential caves that someone zapped with a GPS, and no one's gone back to since. So it would be nice to have a way of solving it. I think it's called the Milkman problem in mathematics, or the salesman problem, or whatever. The other thing I wanted to ask is if you can override the ridge walking routine so that you can visit specific points first and then the rest. So if there's one or two that you really want to get to in a day, and then the rest will come out following your algorithm. There's
Never
no need
thought
to
about
answer.
that.
It's just something to think about in
Yeah,
terms of customizing it.
I'll tell you this.
Um,
I'm sorry. Do you want? Can I answer that one real quick? Can I give you feedback
oh,
on that one?
if you want to answer it, but it's just food for thought for you as a developer.
I like to keep CaveFinder simple enough that it's appealing to a lot of users. So even though there are features that maybe I would like, sometimes I worry that it will be overwhelming to the more casual users. And I've gotten that feedback before. But what you just suggested, I love the idea of adding that for the standalone Ridgewalk planner. I'm going to do that. I'm going to make it where users can adjust their list of points and override the default. That's a wonderful suggestion that I'll make sure to do.
Okay. Is there any in Greece? I'm from Greece. In Greece, we have the shuttle data, SRTM, which is 30 meters. Is there any way that that might be useful or
I'm
usable?
going to look at. I'm actually not. You said it's SRTM. I'm going to look that up.
Yeah,
Since it's at
it's the
30
space
meters,
shuttle radar something mission.
yeah. If it's lidar data and it's 30 meters, I know it's not
It's
great with K-Finder.
it's not
If it's
LiDAR, it's radar.
I'm going to look into it because you have me curious and I have it written down. And I'm like, a lot of the research I do to improve data is
The
is to access different things other than lidar. I'm always looking for anything I can add to the formula to improve K-Finder.
Okay. The other thing, I'm not sure if you already mentioned it while you were talking. You said you can put a user generated LiDAR plot in the software.
Yeah, I've it's got that functionality on the back end, as in to say it's all programmed up and ready for that. I don't think I've actually made it where like it's clickable where a user
Okay,
can
okay.
do it.
But
But that's minimal for me to
I
add.
don't
As soon as
have
if
I don't have a plot yet, but if I did have, or rather, it may persuade me to pay the money and get someone with a drone to make a LiDAR plot of 1 square kilometer that interests me, and then I would definitely be interested in using the app.
That would be a great case for it, because the drone LiDAR flights are usually higher quality even than the other 1 meter resolution ones. So that's a fantastic use for CaveFinder.
Okay. And the last thing, in the example you showed us, the big pit had 3 dots on it. What happened there? I mean, was that something you expect, or something that is strange for you as well?
So I'm looking at it right now. Some of those points, and I needed to make this better. It's not really, I'm realizing this is a little confusing. One of those points is actually from where I typed the coordinates into the search bar and hit search. It made a point right there when I did that.
Okay.
And then one of the points, candidate points, is indeed that cave. There's one slightly north of it. That's another known cave that's smaller. And but
okay.
It's in that. And then when I actually make a search analysis, actually no, there's a mystery point in there that I have a known cave layer. So there are some cave data in the United States that is publicly available that's not secret or anything. It's caves that are like super well known, like show caves and caves that everybody knows about. One of those points is from that known cave layer. I'm looking at it right now just to see. Yeah.
But it was very interesting to hear you, and we'll see what happens with LiDAR data in Greece from the state or else from private sources. But unless we have something of good resolution, we'll have to wait or just use your ridge walking app.
Emma mentioned it to me. We met just right before the meeting, just to start going over things. A lot of help it did. I still got to click share screen, but she mentioned to me that she read that, I think it was Slovenia or somewhere, that has 1 meter resolution data. And I'm literally like, I've got to get back to work after this, but later this afternoon when I get off work, my priority is to research that 1 meter data for the Balkans and whatever parts of it.
And they in Slovenia, they've been using it to enrich the cadastre of caves and to revisit areas that were visited in the 80s by foreigners, you know, when GPS didn't exist. And they have a bunch of surveys without entrances. So they're using that new LiDAR data for rediscovering those old caves.
It's a great use for it. And I'm hoping I can get access to it for y'all, for the people that in that area that would be interested in using CaveFinder.
Okay. I thank everyone for their patience in letting me say all my questions.
Stelios, if you're, not sorry if I'm getting that pronunciation wrong, but if you're interested in testing the Ridge Planner app, just reach out to me. You can find my contact information on the CaveFinder website, and I'm going to put my email in the chat as well. Or for anybody interested has any other questions or interested in testing either the test version of CaveFinder. CaveFinder is always like, I always have a version in test just to make sure it works good, but the test version is usually like way better than the live version. So if anybody's interested in any of that, just feel free to reach out to me. I love chatting about the project. If you can't tell, I'm very proud of it. And I doubt y'all or anyone here is going to the National Speleological Society convention in the United States here in a couple of weeks. But if anybody's there, I'll be there presenting on CaveFinder and love to chat more about it. There's my email in the chat.
Okay, thank you.
Well, thank you, guys. Anyone else? If you have questions, you can type them in the chat or you can address them directly.
Thank y'all.
Okay, so it seems that we don't have further questions, but I want to thank you again for showing us your work. And also, if anyone else would like to have a presentation, please let me know for future. And we have the messages from Marilena. She's congratulating you. So thank you for participation.
Thank y'all.
And if
Yeah,
you don't,
I'm gonna go. I have to get back to work. But again, thank y'all so much for having me. And if anybody has any further questions, comments, wants to get involved in the project, advice, anything like that, feel free to reach out to me. Bye, y'all.
okay,
Thank you very much.
you.
Best work. And thank you, Emma, for hosting it.
Thank you very much. So, bye-bye, all.